Okay, everyone, without further ado, welcome to Kubernetes Fortnight, Simplifying Advanced Network Configuration with Luigi. I'm happy to have you here today. I'm excited to present. But before we do, let's go through a couple of things. We're on the session. Join the Slack channel, hashtag AMA. This channel will be used to submit your questions, comments, and media. And I do encourage questions to be asked. We do have people monitoring them, whether it's myself or Arjun presenting. We'll be able to possibly answer them right in the middle of that conversation. So this is very informal. So if a question comes up, we'll try to answer it as it comes up. Also, I encourage everybody, if you do not have an account now, create a Platform 9 free account. We do have a free tier. It's fully functional. It's a great way to dip your toes in the water, or if you are an expert in Platform 9 or just an expert in Kubernetes and wanting to see how Platform 9 can simplify deploying and the difference between, a do-it-yourself kind of putting everything together versus managed Kubernetes. It's a great way to walk through it. There's also tutorials. There's lots of great resources through it. I highly encourage you to do that. So feel free also to share this with any and all friends. It's an open community, so please share it out and get the word out. So my name is Chris Papp. I'm product manager in charge of Edge Cloud, virtualization, and bare metal. Under that category is also the Luigi Advanced Networking section, so that's where I come in. And I'm excited to be presenting with my peer and friend, Arjun Bendir. He is not only one of our experts in Luigi, but he's also a contributing member to it. So he's actually helped develop the product. So there's probably no one in the company that knows this product or this section, especially like advanced networking topics, better than Arjun. So I'm excited to have him on. And he's going to have the good stuff as we walk through today. We'll cover, what Luigi is and, what organizations are facing. And we're also going to have a great demo, and that's where Arjun's going to come in. And we're going to go through as that process, as you see it in action. You're going to see how using Luigi simplifies, some of the advanced configurations of deployment of networking, advanced networking capabilities or plugins, and where it kind of makes your life easier in deploying those. And so we're going to walk through all that. And before we do, I'm just going to kind of cover on top of that my section of like, what is exactly Luigi? Like, what's a strange name on this product that we have? And then, the why it exists and what it entails. And then that'll dovetail into the demo. So $1 million question, what is Luigi? So when you look at it, although it is a networking operator, a Kubernetes operator, it's also the umbrella name for a project, scope of repo. It is our open source project for enabling advanced technology stacks such as SR-IOV, DPDK, Multus, device plugins, IPVLAN, and MacVlan. It can perform feature detection through NFD, kind of do all these things to kind of simplify some manual and TV processes. In the virtualization environment, if you want to be able to have multiple NICs, or even in a containers environment, multiple NICs, Luigi is how you're going to be able to enable that in a PMK environment. You're going to need multiple NICs to enable those kind of high speed, high performance, low latency networking capabilities that you'll see that are useful for certain networking applications, for example, like 5G networks on the edge, or anything for that matter that just needs like low latency and high performance. You're going to need those additional capabilities. It allows you to deploy multiple container network interfaces, and so that's in a nutshell what Luigi is at a very, very high level. So why does it exist? So, what is that? So it's not a secret. Networking, Kubernetes networking is complicated. It's complicated for a couple of different reasons. You have setup complexity, management complexity, support complexity. The default Kubernetes networking model with one CNI and a cluster-wide network is sometimes too restrictive for many of the advanced networking cases like NVF or virtualization. So there's complexity in that. It's just too restrictive. There's also a lack of a good solution for general networking managers, just one spot to do all the work, where you're going to do that. When it comes to setup complexity, I think it speaks for itself. There's just so many discrete plugins and solutions. Which ones do you use? Deploying and managing them can be tedious. So you not only have the setup portion, but how do you manage it afterwards? What do you deploy? It's expensive in the fact that the time to market, once you get one up, it's its own little snowflake. Right? If you're setting the environment up, getting it going, and you got to set up another environment, there's not a wash, rinse, repeat procedure with it. And when you have these, manual processes, not only they're expensive in time, but they also tend to be error prone. Just human error gets put into it. It's not done the same way each time. So what is the cost of, when troubleshooting, and it takes a long time to, time to resolution, when you're going back through and troubleshooting the steps, and the setup is not exactly the same. You also have the support complexity involved of, when you're doing this, what secondary CNI is, what are the dependencies, in which order, how do you find the current networking state? How do you know, how to configure your nodes to support all these different configurations? It's easy if you're just doing one, but once you're starting to deploy that out to an entire enterprise environment, that becomes one to many, and a lot of issues can happen from there. So that, these problems that we see just in the environment, you could also take these, setup complexity, management complexity, support complexity, and apply it to anything. But in particular for networking complexity, it's very expensive in admin's time, bottom line, and the ability to be agile, right? Those are the penalties that are paid. So that's where we came up with Luigi and what it's supposed to do. So we talk about, Luigi providing the capabilities to deploy these advanced technology stack support. And we kind of go through there, and I've brought it up a couple of times. What are those things? Like, what do we support out the box? Well, if we're talking about something like Multus, like you need this to create a multi-home pod that has multiple interfaces. In the case of like whereabouts, for instance, it's IPAM. So if you need whereabouts or an IPAM capabilities, you're going to need to deploy Luigi to be able to make that available. And it's easy to do from like a centralized networking management function. When we talk about performance of speed, of course, we're talking like SR-IOV, DPDK, there were network plugins that, the virtual functions available on Kubernetes host based on conf maps to deploy pods with higher performance NICs. You'll see this often, and you'll also see them not just in a Kubernetes or containers environment, also in a virtualization side, to be able to enable that, enable those multiple NICs at high speed, and you get the performance that's required. So we're able to do that. And for instance, if you're trying to do SR-IOV, you're going to need to have multiple NICs. You're going to need Multus, and once you set it up and you're able to kind of deploy it, and make it very easy to kind of do that and push that out all the way through. So what are the different components? And this is just a very overly simplified kind of layout of what we have. So we know that Luigi is the overall kind of umbrella, and it's the operator that simplifies the configuration of the technology stacks. But under that, you also have host Plumbers, which is a Kubernetes operator-based solution that helps configure your nodes for those advanced networking use cases. What it does, it actually defines two new custom resource definitions called host network template and host network. And those are used to configure the host networking and view the networking state. The host plumber runs as a daemon set on each node. It's responsible for discovering the host's initial state and then populating the host network CRD. What can it do? You can configure SR-IOV, VFs, and drivers. You can create VLAN interfaces, create OVS bridges. You're adding interfaces, device MTUs, IP addresses, and routes. When you're talking about the host network template, each pod in the data set for a host plumber controller will watch for changes in creation of the host network template CRD. Then its reconciler will enact the changes specified. That's different from when you're talking about from like the host network. I don't want those two confused. I don't want the host network CRD to be confused with the status section of the host network template. The host network CRD is not created by the user. This is a read-only CRD, and the daemon set operator on each node will publish various host settings to the CRD. And you basically like created first upon the daemon set operator is being deployed, updated after each application of the host network template CRD, and then updated it as a periodic task or plan. So those are the general, like that's a 50,000 foot overview of like the components of a Luigi. You'll see these different components come up as Arjun kind of provides his demo and walks through. So, and he starts providing those advanced functions in a real live environment. So turning this over now, we'll start to jump into our demo. But before I do, I'll pause right here and I'll see if there's any questions. Mike, are there any questions or anything that we need to address right now?
So I don't see any questions yet. I'll do a poll here in a second and see how many people are interested in like setting up advanced networking for their Kubernetes stack, or if they're just using like a default like CNI, like I don't know, like Calico or Flannel, or if they're actually getting advanced with it yet.
Yeah, I'm also curious. One question that I'm curious about too is how many people are actually looking for advanced, if they are looking for advanced functionality in the network configuration. Is it for virtualization or is it for your container functions, right? Are you trying to set up KubeVirt and then get that high performance out there? Or is it actually, you're trying to set up that high performance to pod? So I'm curious for that as well.
All right, I'm gonna get a poll one here in a second so everyone will see that pop up. I guess we want to go ahead and get the demo started and maybe we'll get some questions around that.
I'm going to stop sharing. Arjun,
okay.
Can you start sharing?
Hey, you guys can hear me fine?
Yeah, hear you great.
Hello?
Yep, we can hear you.
Okay, perfect. So let me share my screen here. Okay, perfect. You guys can see my screen?
Yep.
Okay. So if you go on our repo, we have a bunch of samples as well as README. And for now, I think Chris talked about, we have two actual operators, Luigi and Plumber. They're both in the current repo right now. We might break them apart, but I suggest going to the top level, platform9.com/Luigi, and you'll see here how to deploy Luigi itself, and I'll show exactly how to do that. And then there's if you go to the host number folder, that's actually the host number operator. This is an independent operator too, actually, so you can use this just for configuring network state on your nodes. And poll just popped up. So yeah, so you can use this independently to configure the networking state of your nodes. It's not really tied to Luigi. The way to best think of it is Luigi is it's basically an add-on operator to manage the more advanced networking plugins. And host number is an operator to actually configure and prep your nodes for whatever is required for all those things, right? Because to use OBS or SR-IOV, MacVlan, it frequently requires you to configure a bunch of stuff on your node that may not already be there. So
we have a question, Arjun. Let me ask you this. All right, so is this only supported in Platform 9 K distribution, or can it be used with any Kubernetes distribution?
It should. There is. I try to make it so it's independent of our Platform 9, so there should be no Platform 9 specific bits in there. It should work. Yes, it should work on any Kubernetes cluster. You just need a cluster that's already up and running. So as I say here, in order to use this already assumes you have some working Kubernetes cluster. You have core DNS or whatever you're using for DNS running. You have a primary CNI up. I've tested this on Calico, so but it should work as long as you have a basic cluster.
I would also add that moving forward, you're going to see increased support from platform providing and contributing to the open source community. You'll start to see continued support as time goes on and the feature set grows under the Luigi umbrella, and you'll see that still be represented as available to open source as well. You're not going to see that kind of be tailored just to run on PMK. It'll be fully available.
Although with Platform 9 PMK, Luigi itself is integrated in it, and then we deploy even this operator itself. But this and host plumber itself are both independent operators. You should be able to use them. And yeah, so why don't I just show exactly how to do it, and I'll show the manual way. So you can do this on your cluster without assuming that you don't have a Platform 9 cluster. So here, so I have a cluster. I mean, if you're familiar with our Platform 9 UI, here's my cluster. It's nothing fancy. It's a single master and has 4 workers up here. And these are all bare metal nodes that are deployed from Equinix Metal. So, and I believe 2 of these nodes have SR-IOV enabled in the BIOS. So these are actually SR-IOV capable. And if you want to, let me make my screen bigger.
All right, Arjan, we got a second, like a follow-up question too. What is the underlying CNI it supports? Multiple or?
What was the question?
What is the underlying CNI it supports? So like this lets you use multiple, right?
Yeah. So it doesn't depend. Do you mean the primary CNI of the cluster is running? That should not matter. You just need a running cluster with some kind of CNI, whether that's Flannel, Calico, whatever. And as for Luigi, it's not so much that Luigi supports CNI, right? It deploys other CNIs, and for now, these are all the plugins that it supports. So it will, as I mentioned earlier, it's more like an add-ons operator to deploy, manage, and upgrade these, as well as configure them. So you don't have to worry about what repo do I go? How do I install it? What do I need to configure? The goal is you deploy Luigi, and it will automatically take care of deploying all of these plugins. So host plumber, this is the one that I talked about. It's our own other operator. You can just do all of this, and I'll show you exactly how to do that. And this is recommended unless you have your own kind of tooling in place to get on every node or craft it. Multus, this will you can deploy this, and this is pretty much almost always required if you want multiple CNIs, and that's probably why you're here. That's the first thing that people hear of when they're like, how do I create multiple networks in Kubernetes? And Multus is the only way to achieve that. It also deploys SR-IOV CNI. It also deploys SR-IOV device plugin. It will also deploy Open vSwitch itself and the CLI tools like VSCTL and OFCTL. And so this is actual switch daemon itself. It also deploys CNI plugin that's required by Kubernetes to use Open vSwitch. You'll have MacVlan, IPVLAN, whereabouts. If you're not familiar with whereabouts, it's a IPAM driver that allows dynamic IP assignment. And the reason for this is, there is a DHCP IPAM plugin, but it doesn't actually provide a DHCP server or services. So barring that, whereabouts is an IPAM driver that kind of allows dynamic IP assignment without configuring static. And then there's another plugin called Node Feature Discovery. We just use this as a handy way of labeling nodes, and you'll see later what it does with labels that can be used by host plumber and for your own purpose. Does that answer your question?
Yeah, I think that was great.
Okay, cool. So going back to that, I have a cluster. You see, it's just the basic cluster right now. We don't have much of anything running here. These are some PF9 monitoring services here. You can ignore those. These are not required or used by Luigi at all. But other than that, you can see it's basically we have, the KDS API server running. Now we have core DNS and we have Calico. And as mentioned, you need any CNI running, a primary one. We're using Calico in this case. So, and it should work with Flannel or any other CNI running. So we have this. Now, how do you deploy Luigi if you want to do it on your own? So if you go to the samples folder here in the Luigi repo, just go to samples. You just want to deploy this Luigi plugins operator .yaml. You go to it. This defines the whole the main operator spec. So we'll be creating its own namespace for itself. It'll define all the CRDs for it, RBAC components. That the main thing to note is that it's just basically deployment, and it has a replica of one. So I already have this. You can either, if you want, then you just get the raw version of this from GitHub and then kubectl apply it, or git clone the repo and just apply it from there, which is what I'm going to do. So I will just do. So now we have the main Luigi operator, which is going to be running. It should be running right now.
So all you've done so far is deploy like a vanilla deployment of Kubernetes. Are you deploying on bare metal? Or are you using virtual machines? Okay.
These are all bare metal from Equinix metal right here.
Okay. Awesome. You don't have to show. I was just making sure it's bare metal based. So this is going to be like, maybe I've got something bare metal servers in a data center or on site, and I'm using this after I've deployed Kubernetes on it.
Yeah. Yeah. So
you just go back to the demo if you want. You don't have to show the things. I was just trying to make sure it wasn't a.
Yeah, that's fine. So I have, I think I mentioned, I have 5 nodes here, a master and 4 workers right here. So this one.
We're doing it live too, so demos can fail sometimes. So we'll see. It's a little bit slower, but hopefully we can get going.
I just had this running and I cleaned it up before I verified it, so it's going on here.
Not a problem. I think everyone who's created a demo has run into, oh, is this working? Please work like as it's going.
Yeah, that's right. I need to, you can't reuse Multus. I know how to fix this. Okay.
That's just because you deployed it previously and it still has some configuration still, or?
Correct. I had it deployed and I had Multus, and then I deleted everything, and now Multus is trying to reinstall itself. So I did not instead of me following the full path of things. I think. Should I just recreate my cluster, or?
Yeah, you can do that. Maybe we can have like Chris talk about some stuff too, and then just like recreate it. So it only takes like a minute or two. So we're gonna recreate it. Some live demo fun.
Yeah, so as he's going through this, one thing that you can do as well is if you go out to, or you just Google Luigi networking, platform 9. You should be able to get to the GitHub repository for that. All the information is there, but there is additional information, contextual information like definitions, terminology, how it's laid out. If you go to platform.com, platform9.com/docs, and just search for Luigi in that, you should be able to find plenty of information. But in terms of installing and setting up, you should be able to find all that on GitHub as well. You'll see, you're going to continue to see us develop and expand the feature set for Luigi and its capabilities. You'll see that filter through to the GitHub repository as well. So you'll see those features if you're running on the cloud. You'll be able to access those, of course, and you'll be taking advantage of that. But if you're trying to run this on a different Kubernetes distribution, you'll still be able to get that functionality from GitHub as well.
And I put a link in the chat to Luigi. I'm going to put information about the docs in there too in a minute. And Arjun, just I muted you from it.
Just trying to search for it. I was trying to search for it while I was talking.
So what you're seeing right now is just Arjun go through quickly deploying a cluster using our UI. Here, let me go ahead and provide the documentation. And like I said, Arjun, I muted you for a minute just so we could talk over while you're doing this. So as soon as you want to come back on, unmute.
Okay, so now I have deleted my cluster. I'm just going to reclaim quickly. I'm just going to deploy a single master cluster here again.
Say for everyone who hasn't seen the UI, like if you're new, this is our UI. This is how you create a cluster. Right now he's checked in a couple of bare metal nodes. And here you can actually go through and you'll be able to select which nodes you want to add to the cluster. So what is he doing? He's removing make master nodes, master and worker. That way just the worker nodes will run workloads. Are you you're enable the network plugin operator, right? Like, or you're doing that after?
No, right. I'm not going to do this just to show how to deploy it manually.
Okay, so you could do it. Yeah, so you could do it with the UI here, or you can do it manually, like he's going to show.
As mentioned, this is part of PMK, and it will deploy and manage it for you. But just for anybody else that's not using PMK, how they would do it. So I am not going to be doing this here. So it's just basic setup. One master, create.
So basically that's the creation wizard in our interface.
In the meanwhile, while this loads, this will just take a couple minutes. Let me go through the README and show basically how this would be done. So assume that Luigi has been deployed. What can you do with these plugins besides deploy them? You can configure a few aspects of these. So you can give a namespace or an image override. By default, Luigi, we will test and validate a stable release of these plugin versions, and it'll take care of deploying them for you. You just have to say you want to deploy it. you don't have to worry about what version you want either. But if there is later version that you want, or let's say you're in a dev test environment and you're actually testing these CNIs, or you want to get a bug fix, you can override it with a custom image. This still would not be supported. Use your own risk in case the CRs have changed for those plugins themselves. But this is useful for dev test environments. You can specify other things like the image flow policy. And in some environments, like at least for platform 9, there might be a private container registry where all the containers are hosted privately as opposed to from Docker Hub or GCR or Quay. What you can do is you can set this field, and I'll show how. And this will say pull it from all these container images from the private registry as opposed to the public registry.
So Arjun, let's say I'm doing this myself, like I'm deploying a Kubernetes cluster and I go here and I'm using Luigi. How do I ask questions or find out information if like I run into a problem? Am I posting an issue on GitHub? Am I joining the Slack? Like what's the best way to get community support for this?
I'm usually hanging out in the network plumbing working group Slack. If you guys are familiar with that, it used to be the Intel Slack, I believe.
So you're saying that now that is that in the Kubernetes Slack?
It's not in the Kubernetes Slack. It is.
You don't have to show, or just saying network.
It's this network plumbing working group, and there's some other people here that hang out that work on Multus as well as SR-IOV. So this used to be the Intel GitHub. You could also just file an issue or on the GitHub itself, and I'll respond very soon.
Awesome.
So there's some other nuances for configuration. These are specific to these plugins. I'm not going to go into detail about what these are, but Whereabouts is an IPM driver and has some other features that we decided the users may want to customize. So these are the options that are available. For now, these other plugins are very simple and there's nothing big. So how do you actually deploy it? Once it's deployed, it's best to show by example. So what it does is we define a new CR called network plugins, and it's as simple as this. So we have Luigi deployed, and let's say you're like, oh, I want all of those things. So you want host number, you want node feature discovery, you want Multus, you want whereabouts, you want SR-IOV, or you want OBS. This would deploy all of them. And I mentioned, whereabouts, I might have some specific configuration. This is optional, obviously. If you don't, there's always a default. You can leave remove all of this, and it'll deploy whereabouts, with the default parameters. I mentioned, there's some other overrides here, like namespace or image override. If you will, by default, it will deploy all these default namespace. If you want to deploy your own namespace, that's fine. You just override it like this. So you just deploy all these plugins here in the cube system namespace. And you would just basically do cut all that. See, clusters up. So should have another healthy bare bones cluster here. Now, go here. So now this should work. Okay, so now we're running. We're good. As you can see, we have a Luigi controller manager running in the Luigi namespace. This will be scheduled on one of the nodes. It's just a deployment of one replica. So now, obviously, I've deployed Luigi. It's not going to do anything right until we actually use the network plugins CR to deploy all of these plugins here. So as I mentioned right now, it supports all of these plugins. So let's see what I want to deploy. I have a sample plugins here. And just to make things simpler, I'm not confuse you guys, I would just leave all these blank if you don't, unless you really care about the details of these plugins or know what you're doing. So you want host number because you want to configure your nodes. You want node feature discovery. You obviously need Multus. You most likely need whereabouts unless you're using static IPs. You probably want where SR-IOV. That's probably also why you're here. Or you want OVS because you're interested in KubeVirt or layer 2, getting access to layer 2 type network. So it's going to deploy all of these. All I have to do is create them. And I didn't specify any image overrides or namespace, so these should all be default namespace. So now you can see we have host number, we have Multus, we have SR-IOV, we have even OVS, we have OVS daemons, which is where actually Open vSwitch will run. We decided to run it in a container rather than install Open vSwitch, say, directly on the host, just because this would allow us to account for any kind of dependencies and make sure that it's always running. So we run Open vSwitch as a daemon set as well. And here we have whereabouts, which is the IPM driver, as I mentioned. So now we have all those running. So now, obviously, before you can do that, we should jump into host number here, right? Because let's say we want to configure SR-IOV. Before we do that, you need to know how to enable and configure SR-IOV. And what else does host number do? We can create VLAN interfaces, OVS bridges, MTUs, IPs, and routes, and we have more planned in the future. Open suggestions as well. We can have a do sysctl, bonding. The goal is that this is just a operator that will help you configure it. The best way to show what it can do is a comprehensive example here. So if you look through this example, we have a template here. This is also available in the sample repo. If you just go to host number, or sorry, go to Luigi. And then if you go to samples, we have a sample here to host configs. I believe this is the same example that I have here. So this might seem like a lot, but this does a few things, right? So first, we have a node selector. Normally, this will apply this network configuration on every single node in your cluster, which you may want. If you don't want that, you can target a specific node or a subset of nodes using node selectors. All that you have to do is label the node, and then you can selectively apply it. In this case here, we're using a label SR-IOV capable, and this was automatically added by the node feature discovery service. So that was one of the cool things. So that's why we also decided to deploy node feature discovery. So for example,
I'll say that's helpful, right? Like in case, say I've got like bare metal nodes on-prem that support this, but then I've got a bunch of VMs running too, but they're in the same cluster. I can say only run pods that need multiple NICs on my bare metal, right? Like that's how this helps out.
Yeah, right. So you can configure node feature discovery once it's deployed on your own. That's a whole other beast. You can have it detect a whole bunch of other stuff, but out of the box, we discovered one of the cool things is that it discovers SR-IOV capability automatically, and it automatically label the nodes for you. So you saw I didn't do anything. I just deployed node feature discovery. So if we describe the node, you can. So if we describe the node, we can see that it has Um,
Looks like it's there in the labels, right? Capable, true.
you see, oh yeah, sorry. Yeah. So
Like
you can see
this,
that this node is already labeled. So this is where I can say, oh, I'm only going to target my nodes that are SR-IOV capable.
is there a way to view this easier? Like, is the API let me say like just show me nodes that are capable, or do I have to do it like a search based on label or something like that? Like, say I've got like 50 nodes. Like, is there a way to show, or is that like maybe future feature?
I don't know the question for that off the top of my head.
Okay.
No. Anyways, so now we have, so we can see that the node is already labeled. So now how do I actually create some of the stuff on those nodes? So, well, what else does this config do? We have SR-IOV config. So what it's going to do is it's going to create 4 virtual functions on the NIC ENO2 with this VF driver. It's also going to create 3 VLAN interfaces on ENO2. And on top of that, it's going to create an OVS bridge called OVS BR01 and on the VLAN interface ENO2.1000. So that's a lot, right? This is just a more comprehensive example, kind of show, what a full config template might look like. You don't have to put it all in one config template. You can split them up per section. Just apply a different template. As I mentioned, you can apply as many as you want, targeting different nodes using labels.
So Arjun, we got another question.
Yeah.
Have we done anything with the Cisco ACI with this, or have we? Does it support Cisco stuff or anything like that? Cisco question from Enrico.
Cisco.
Or we're mostly looking at open source things that we can use. Like, have we done any testing? So the question basically is, we're running on production enterprise containers using Cisco ACI to manage front and back end traffic for the management pod ingress. So they're managing ingress with Cisco ACI. Everything on the network plane is ACI. Can they use Luigi with this to create multiple NICs, or is that kind of like, is it kind of like competing with it, right? Like, would you use ACI versus Luigi? Like, Luigi would be an open source option to replace ACI?
I don't know anything about
Okay.
that. Sorry.
Enrico, we'll see if we can get some information about that and maybe reach out.
So sorry, where was I? So here, this is a comprehensive example, right? It does a lot of things here, just to show, kind of more comprehensive functionality. If we dive deeper here in the README, we describe actually what some of these sections are. We have an SR-IOV config section, and the main thing is, you can say, okay, these are the number of virtual functions I want to create under the device, and which VF driver to use. So, for example, traditionally there's a kernel driver associated with the device, I40EVF, IXGV, or if you're using DPDK or Kubert, you would be using the VF-IO PCI driver. And it's as simple as saying VF driver, use this one, or VF-IO PCI, or I40E, and we'll configure everything for you under the name, the NIC, aka the physical function. You can separate out into 2 separate templates here, saying, create on this NIC, create 8 VFs, on this NIC, create 4 VFs. Another way to filter is, we can use vendor and device ID. This might be useful, say, if you don't know the naming of the NICs on your hardware, it may not be ETH0 or this across all your nodes. You can target by device and vendor ID to say, all Intel NICs of this particular model. Go and create 35 virtual functions and use the VF-IO PCI driver. And it would do this on every node, because remember, we don't have a node selector here, as we did in this example up here. So, what this would do is it would go on every node in your cluster and create 32 virtual functions on every Intel NIC that matches this 1528. So this is like the Intel 7X710, for example. It would go and create 32 virtual functions on every Intel X710 on the host. Another way to filter is, by PCI address. So this is just another way to do it. We have by name of the NIC, so the name of the physical function, name, device, and vendor ID, or PCI address. Whatever is your preference. I typically, use either vendor device ID or the name of the physical function itself.
Sarge, I had a question. So the demo, basically you haven't defined anything, so it's just setting up everything, right? Like to where, like if I know what I'm using, I might go in there and define a couple of things in the sections you left blank, right? Like if I'm using different stuff, like the basic install you did is just like, hey, I'm just going to set up a cluster, deploy this. It's going to set up everything. If I want to get fine tuned or something like that, then I'm going to go ahead and edit all these settings after I kind of understand what's going on. But I can get started and have multiple NICs like in what, like 20 or 30 minutes after getting a cluster running.
Yeah.
Okay.
I'm going to create. So the first thing to do is, this is just nuance of the SR-IOV device plugin. If you're familiar with SR-IOV, you have to define a config map for the device plugin that states what devices to watch for. So what I did was I just created a config map here, and I'm saying on this resource, give it a name, resource kernel 1, I watch for ENO2, I40 EVA. If you're already lost right here and you don't know, not concerned about SR-IOV, you're not familiar with the device plugin, then you can ignore this. But this is specifically the device plugin that we deployed earlier. This is just one of the steps that's needed to get SR-IOV up and running. But let's say I've done that. So this still doesn't create the virtual functions, right? So I was going to demonstrate what host number would be doing to create those virtual functions. So let me create it now. I believe I have this example here. This is an example from the README, but let's just go with the more normal example. Normally you might not be trying to target all this in one giant template here. So for now, let me just comment out the OBS config. We can save that for KubeVirt demo. All I'm going to do is I'll demonstrate the creation of SR-IOV. I'll create some virtual functions and I'm going to say use the I40 EVF driver. So as I mentioned, I'm going to leave this node selector on there so it doesn't go and try to do this on my master node, which is not SR-IOV capable. As I remember, I showed the describe node output up here earlier, and this node is one of my workers where I have enabled SR-IOV, and master does not have it enabled in the BIOS. So it wouldn't make sense, apply this config template on that node. So what I'm going to do is so we've applied this template. This is my this is my worker right here. So if I do IP link, we should now see. See. So we have 4 virtual functions that have been created on ENO2, just like I said. And on top of that, I said I wanted 4 VLAN interfaces. These would be used for MacVlan networks. And we can see that we've created 4 VLAN interfaces on ENO2, VL1000, 1001, 1002. And the reason for this is that the MacVlan CNI doesn't support VLAN tagging. So one of the only ways to get VLAN support with MacVlan is, you have to use VLAN interfaces. And obviously, VLAN interfaces can be used for a lot more. That's not restricted to MacVlan. If you want to manage an interface, whatever. But so that's why that's the main driving reason why we added the ability to also be able to take this. So now we have all of this done. We look on our other node here. We should have it created. If we look on our master node, you can see this template was not applied under my master node here. And as stated earlier, that's because it's not SR-IOV capable. So we don't have any virtual functions under ENO2, and we don't see any of those VLAN interfaces created.
So good demo, Arjun. Thanks. I think this is a great introduction to Luigi. We should hopefully be putting out more information around it if you're interested in using it. But very, very good demo. Thanks for showing it off. A little bit shaky. Glad we got the cluster deployed really quick and we're able to show how it was set up. It seems pretty easy to get started. Probably super deep to get configurations exactly how you want if you're using custom stuff. But
can I show one more thing that?
Yeah.
Quickly, yeah. So I was just going to show that if you can read here for interface config, what else it can do? You can also configure IP addresses on your nodes, and OBS, which I didn't do. We'll save for a Kubernetes demo. But the other side of host Plumber is there's a host network CRD. One of these is going to be created for each node in your cluster. The name will be the name of the node name. In our case, we're using IPs as node names. This is created immediately when host Plumber is deployed, and it's periodically updated, just so the configuration is enforced. But the main reason is that this also gives you a way to view the networking state of your nodes and say to verify that all of this stuff has been created. You don't have to get on every node. So if you did, for example, kubectl, let's say one of these nodes is the same node that I was using. Let's say you just did a get on the space source. It's going to print out all of the networking information. So it's going to print out all the Ethernet link layer information. You can see ENO1, we haven't enabled SR-IOV, but it does support it. ENO2, you can see information for all the virtual functions that we created. You should be able to also see the entire routing table of the node as well. So this is just some handy way for you to verify that what does my node look like, the config it applied correctly, and you can view all the detailed information for each virtual.
awesome. Thank you for the demo. I learned a lot. I hope everybody learned something. This is what we do on our Fortnights though. Usually it's going to be a presentation and a demo or going over like topics related to Kubernetes. Sometimes partners we bring on to talk about different products that we find interesting. Every 2 weeks. So next one should be 2 weeks from today. I believe that's the 27th. So if you want to come to the next one, just check out, we should be able to send out information on our social and stuff, and just keep an eye on our Twitter and LinkedIn, and you should see information about it. We also send out emails with information about joining the next one. But I hope everyone enjoyed the presentation. If you have any questions, definitely join our Slack and ask questions in there. We'll try to answer them as quickly as possible. Or if you have questions about Luigi, maybe use the issues section, like if you're using it and run into problems, that way we can fix them or look into them and help you out. But thanks everyone for joining.
I would add one thing to that, not only just issues, but if you have like feature requests or use case scenarios that you think that would be beneficial to have in Luigi, I am all ears. I would love to hear from you and walk through your use cases. So please reach out with that as well.
Yeah, whether that's adding support for a different type of CNI or a plugin that you've heard of that you think would be required, or configuration. There is some stuff planned for this, like what we've done to support, as I mentioned, and maybe a bonding configuration already.
Sounds good. Say thanks everybody for joining. We're gonna, I think, wrap there. I said join our Slack if you have questions or anything like that. And this video will be posted to YouTube in the next couple hours. I need to do some editing, but thanks for joining. All right, bye.